Welcome back to part 5. Part 5, we're going to actually verify the identity, and we have a part 6 actually. I didn't warn you about this, but we do have a part 6, right? The trig expression as an algebraic expression. That's too easy, okay? So you guys, from 43 to 50, we're going to try number 49 together, okay? 49 looks like this. Please write this down because I'm going to do it on a separate sheet, okay? So cosine of x plus y, they want us to prove. You're pretty good with, and you're pretty comfortable with proving identities now, right? So I'm going to prove to you that it does same thing on left-hand side and right-hand side, okay? So we're going to start with the left-hand side, and this is number 49, okay? Number 49, section 5.4, okay? We're going to start with the left-hand side, okay? I don't know, I don't always try, but I always try with the left-hand side, the more complicated side, right? Okay, so now, we're going to apply the sum and difference here and sum and difference here, of cosine though. So I'm going to rewrite this using left-hand side. That's going to become cosine of x, cosine of y, minus sine of x, sine of y. Try it on your own if you want to. But of course, I'm going to multiply that sucker with cosine of x, cosine of y, plus sine of x. I'm going to erase this, okay? Sorry, sine of x and sine of y, okay? Right. Now, that's the left-hand side. It became that, okay? Try to digest this. If you don't understand, hey, poke someone to the right of you and ask them. And what I'm going to do is I'm going to multiply this, right? Distribute. So I get cosine squared x, cosine squared y, right? Minus, but it's a minus b times a plus b. So it's going to be sine squared x, sine squared y. All right. Then what happens? You're like, but that doesn't look like that. But remember, you need one cosine squared and you need one sine squared. Keep your eye on the prize. So let's, I don't have a cosine squared y here, so this kind of is like, I want to get rid of that sucker. So I'm going to rewrite this guy as 1 minus sine squared y minus sine squared x sine squared y. Okay. Now I'm going to distribute, right? When I distribute, I get cosine squared x, right, minus cosine squared x sine squared y, minus what you see on this side. And you're like, how does that help me in any way possible, right? But you're like, what the factor? So what else? So you know you need this, so leave him alone, okay? Leave him alone, okay? Do they have anything in common here? So let's take this, let's leave that alone, okay? Do they have anything in common here? Sine squared y, sine squared y. So let's pull that out. Take out a sine squared y negative, and what are you left with inside? You're right, cosine squared x. Oh my god, oh my god, oh my god! What is this? That's 1. Exactly. So you get cosine squared x minus sine squared y. What? That's the right-hand side! Hooray! You finished. Because this guy is 1, right? Okay? So you got to look out for those. So these are a little bit more advanced, but I know you can do it, okay? So try a couple more of these. Remember, these are number 43 to 50, okay? And this was number 49, okay? 49 was, I think, was a good one. It's a pretty meaty one, okay? All right, now we'll do the final part. I know you've been waiting for this moment. Drum roll, please. Write the trig expression as an algebraic equation. As you can see, number 53, section 5.4, sine of arctangent of 2x minus arc cosine. Oh my god, they're back! Your worst enemy, arcs, inverses, right? So let's try to do it this way. Let's just do it slowly. Let's let u equal arc tan 2x. Oh, I know what you were saying. I think you were saying that this reminds you of the sum and difference formula, maybe the difference formula of a sine. You're right. We'll get there, okay? That means tan of u is equal to 2x, correct? Right? Isn't that what this means? Because arctangent of 2x is u. That's your angle. That means when you take the tangent of the angle, then you get this ratio. That means if you had a triangle, here's what it looked like, right? Tangent of u is going to equal 2x over 1. What does that tell you about the hypotenuse? Exactly. Square root of 4x squared plus 1. Exactly. Why don't you do the same thing for this guy? Let's let v, because we're trying to get it into sine, u minus v, right? Let's let v equal arc cosine of x. That means cosine of v is equal to x, right? So try that triangle now. Draw it out again. Here is your b. It's x over 1. So what is this guy? 1 minus x squared. Okay, digest that a little bit. There's nothing new here, okay? And nudge someone next to you. Or ask Miss Chang, isn't this really sine u minus v, right? So isn't this really sine of u, right, cosine of v plus sine of v, right, cosine of u, right? Isn't that what that is? So go ahead and do that. What's the sine of u? You're right, it's 2x over square root of 4x squared plus 1. What's your cosine of v? Cosine of v is x. Plus, what's sine of v? Go back here now. Sine of v is 1 minus x squared all over 1, right? What's your cosine of u? Cosine of u is here. It's 1 over square root of 4x squared plus 1. And when you multiply all this and you simplify nicely, here's what I ended up with. 2x squared minus 1 minus x squared over square root of 4x squared plus 1 is your final answer. It looks like a tricky, dicky question, but it's really not, okay? So don't worry. Oh, but I didn't tell you that there is a part 7. All right, so here's a part 7 for you. It's because I'm so worried that you're going to get stuck. I don't want you to get stuck. Find all solutions of the equation in 0 to 2 pi of this equation, right? It's an equation, okay? You can see how this is sum and difference of sine. So you can kind of guess what you're going to do. So if you think you're ready for this, go ahead and just try all the assignment practice problems. But if you want to watch, go ahead and continue watching. So I'm going to apply the sum formula here. Sine of x, cosine of pi over 3, right? Plus cosine of x, sine of pi over 3, okay? That's that whole first part. Plus sine of x, cosine of pi over 3, minus sine of pi over 3, cosine of x. But that all equals 1, okay? Now calculate, right? Calculate, calculate, calculate. What's sine of x? I don't know, so leave it alone. What's cosine of pi over 3? You know it's half, right? So I'm just solving the equation. What's cosine of x? I don't know. What's sine of pi over 3? You know that's going to be root 3 over 2. Plus sine of x? I don't know. Cosine of pi over 3, because I'm just calculating each individual, okay? Cosine of pi over 3 is going to be half. Minus sine of pi over 3, root 3 over 2, right? Oh, sorry, cosine. So you can leave cosine of x, right? That guy right here. What's sine of pi over 3? It's root 3 over 2. Equals 1, okay? Sorry, equals 1, okay? All right, now if you didn't understand that, please ask, okay? Now, when you simplify all this, let's see what we get. I don't want to put that equal sign here because it's equal to 1. This is an equation. We're simplifying the left-hand side to make it equal the right-hand side of 1, okay? Let's see what we get here. What the factor is this? Oh, I see 1 here, okay? You guys, what is that? What is that? What is that? That's 2 sine of x times a half, right? And what happens to this? Oh my God, it goes away. Now, equals 1, does it? Let's see, okay? Hiya, hiya, because this is a constant half, right? That means this is a constant. So these are all factors, right? So we can cancel that out. So it becomes sine of x is equal to 1. So now think. Where is sine 1? You got it. It's pi over 2. And that's the only solution within the given range. All right? You guys, good luck with everything. And please ask me questions. Good luck. Do your homework. Bye.